Hi guys, it's Mrs. Seitz again. Today we're going to be looking at solving problems with strip diagrams and equations that have a letter in it for an unknown amount. Now we've already been looking at strip diagrams before when we've done our daily word problem with our storyboard. When we always got to the part of what's the action, we usually drew a strip diagram to help us think out the word problem. So that should be a review for you. Looking at an equation that has a letter in it for an unknown quantity might be new. So we're going to look at several problems and try to work them out. So let's look at this first one. It says Mr. Arthur teaches 4th and 5th grade math. He takes twice as much time, which they said is represented by the letter T, to grade the 5th grade homework as he does to grade the 4th grade homework. Mr. Arthur takes 90 minutes to grade all of the work. Which equation can correctly show how long it takes Mr. Arthur to grade all of the work? Well, I'm seeing all. I know all means plus or times. I'm looking around. I see all again over here, plus or times. I see twice. I know twice is a multiplication clue word, and it means to multiply by 2. So just by looking at my clue words, I think I'm going to multiply something by 2 and maybe add because of that in all. Well, let's look at the strip diagram to the side. We have 4th grade and 5th grade. 4th grade has a box and it's represented by T. T stands for the time it took Mr. Arthur to grade the 4th grade papers. Then he said 5th grade took him twice as long, so they have 2 boxes. But all together, it took him 90 minutes. Well, this 90 minutes on the side is my total. Now, when I'm writing an equation, do I usually put the total in the front part with the adding and the minus sign, or do I put it behind the equal sign? You're right. Usually when I am adding something up, my total's going to be in the back behind the equal sign because I usually add up parts to give me my total or my whole. So my total should be back here behind the equal sign. So I can go ahead and get rid of C and D because the 90 is not behind the equal sign. So just knowing a little something about totals, that got rid of half my choices. Now the next part, I'm going to show you a little trick. Do you see how 4th grade up here has a T and a box underneath it? Well, I can put a T in that box. Now look at 5th grade. You notice 5th grade's boxes are the same size as the 4th grade boxes. So since the 4th grade box is a T and the 5th grade boxes are the same size, they're T's also. So 4th grade was T and 5th grade was 2T. So I'm going to put 2T. So I'm looking at my answer choices. I see a T and a 2T, a T and a 2T. But if the question said how much in all, should I be adding the T and the 2T, the 4th and the 5th grade, or should I be minusing it? What does in all mean? Correct. All means either plus or times. So I know I'm not going to be subtracting. So my choice or my answer would be A, because T is 4th grade and 5th grade took twice as much. So we're multiplying T by 2. Anytime you have a number next to a letter, it means to times. And I know that my total is 90. So knowing that your total needs to be back in the back behind the equal sign, and then knowing my in all meant add, that helped me get rid of some extra answers. So let's try another one. It says Mary earned a total of 192 points. There's that total again. Well, these are strip diagrams. They're not the equation with the missing letter or the letter for a missing amount. Now let's go back to what we know about totals. When we made strip diagrams in class, I know when we did it in my class, if we made a strip diagram, my kids, we always learned that the total goes on the top, and then we have our parts on the bottom, correct? Now, sometimes when they do the strip diagrams, they don't always look like a part whole box. Sometimes it looks like this, where it's just one row of boxes. So they don't separate it into two parts. But just remember when we had our total, so let's say my total is 192. My total is always by itself. Where's my total? By itself. Because would you put your total with a part? No. Your total is always by itself. So if I look at choice A right here, my 192 is by itself. So I'm going to keep him. Look at choice B down here. My 192 is by himself. I'm going to keep him. But come look up at C. My 192 is next to reading. Would I put reading next to my total? No, because my total always has to be by itself. It doesn't necessarily have to be on the top, like when we did this kind of part whole box. It can be on a bottom, like in A and B, but it cannot be with somebody else. So C is automatically wrong. D is also wrong because my 192 is here with math. My total always has to be by itself. So just knowing again that total is always by itself, or it's like the last problem, always behind the equal sign, I got rid of half of my choices. So these are kind of easy if you pay attention to your clue words and you know a little thing about total, where total's supposed to be. Most of the time you can get rid of half the choices. Now let's keep reading. Mary earned a total of 192 points on her math test and her reading test. So I know I'm taking math and I'm taking reading. She earned twice as many on her math. I know twice means times two, as she did on her reading. Which strip diagram correctly shows how many points Mary earned on each test? Well, if Mary earned twice as many in math, how many boxes do you think math should be? Should it be one box or two boxes? If you said two, you're correct. So if math is twice as big, math needs to have two boxes. Well, let's go look at A. Here is my bracket for math, and it takes in two boxes. Look at B. Here is my bracket for math. It only takes in one box. They made reading two boxes. So I know B is wrong because math is supposed to be twice as big. So A is my correct answer. So let's try another one. This one says that Josh wants to exercise a total of 50 minutes. Okay, here we got that total again. We don't have strip diagrams, we have equations with an unknown letter, with a letter for an unknown amount with equal signs. So right here, let's take care of this right away. If my total is 50, should my 50 be over here with the pluses and minuses, or should it be behind the equal sign? If you said behind the equal sign, then you're correct. So if I look, this one's behind the equal sign, and this one's behind the equal sign. So I can go ahead and get rid of A and D. I tell you, that total comes in really handy. The next one, it says he exercised for 25 minutes on Monday. So I'm going to kind of make me a T-chart over here. Monday was 25 and 15 on Tuesday. Tuesday was 15. And M is equal to the number of minutes he has left to exercise. So I know if I add up 25 and 15, that does not give me 50. So he's still missing some of these minutes. So the question says, how much more time does he need to exercise? Well, let's look at our choices. B is saying that if I add Monday's 25 and Tuesday's 15 and my missing amount that I don't know, it all should equal 50. Well, does that make sense? If I add Monday, Tuesday, and my missing amount, should it equal my total of 50? Maybe. Well, let's put a question mark. C is telling me I need to take my missing amount, subtract 25, then subtract 15 to give me 50. Well, would all that subtracting end up giving me my total? Would I be subtracting them all to figure out my missing amount? Probably not. And I know what you're thinking, but Miss Seitz, there's a more right here in the question, and more means minus. Yes, you're correct. Now, if you wanted to do it that way, then you would have had to do a problem such as um, 50 minus, and I'm going to use these brackets. We're going to add up the 25 and the 15. I could add up what I have, my Monday and Tuesday, and subtract it from the 50, but that wasn't a choice. There wasn't a choice that said take my total and subtract from it Monday and Tuesday. But you can look at it a different way. If I add up Monday, Tuesday, and my missing amount, I should get 50. So that's why my answer is B. Because if I do go add up 25 and 15, I get 40. Now, if this is 40, how much more do I need to get to 50? 10, right? So if I put a 10 right here for my M, would that make sense? 25 plus 15 is 40, and plus 10 more would be 50. Yes, that one makes sense. So just remember, there's always more than one way to solve a problem. So if you were thinking I need to add these up and then subtract it from 50, you are correct, but they didn't have that as a choice. So remember, with math, there's always more than one way to solve a problem. That's what makes it kind of difficult sometimes when you're trying to pick out which one is correct. Okay, let's look at this next one. We're going back to strip diagrams. Richard has 20, oops, let me get my pen. Richard has 24 gallons of water. Well, if Richard has 24 gallons, to me, that sounds like his total. What do we know about totals? They are usually always behind the equal sign, and if it's a strip diagram, they're always by themselves. Well, let's look at A. Is 24 up here in a row by itself? Yes. How about B? Is 24 by itself? No, it's with a 10 and another 10. So B's already wrong. How about C? 24 is by itself in a row, so I'm going to keep it. D doesn't even have a 24, so I'm going to go ahead and get rid of him. Again, if you know about total, that it has to be by itself or behind the equal sign, we got rid of half our choices. The next part says he has two large buckets that have 10 gallons each. So I need two buckets with 10s. Well, here's two buckets with 10s. Well, look at C. There's only one bucket with 10. I'm getting rid of that C. I'm thinking it might be A, but let me keep reading. He has also one small bucket holding the rest of the water. Well, I have a little small bucket. It's a lot smaller than my 10, and it's on my strip diagram. Which diagram best represents the situation where S is the number of gallons of water in the small bucket? So I'm believing that A is our answer. And if you notice, A looks very much like the strip diagrams we would draw in class when we did our WIN. 24 is my total, it's up on top, and these are my parts. I have a bucket with 10, a bucket with 10, and a bucket that has an unknown amount. All right, we're back to the letter for an unknown quantity. It says Caden, Ethan, and Rory. I'm going to circle that because I want to just keep track that that's 3 kids. Want to run 100 laps around the track combined. Ooh, what does combined mean? Add. So if I take Caden and Ethan and Rory and I add them up, I should get 100. So far, Caden has run 27, so I'm going to put a 27 for Caden. Ethan has run 31, and Rory has gone 17. Which equation can be used to find L, the number of laps the 3 boys need to run to get to 100? So the boys aren't at 100 yet. If I add 27, 31, and 17, let me just go add those. I'm curious. How much have they run? Oh, they've only run 75, so they're not to their 100 yet. So how much do they still need to run? Now, this one's a bit tricky because I think we can all agree that 100 is my total. And here's my equal sign, and none of these have 100 right here. They're kind of being a little sneaky because usually the equal sign's in the back. They put it in the front. Don't let that confuse you. But behind my equal sign, there is not 100. There's L. How many laps do the boys still need to go? So we're going to have to look at this one carefully because usually our 100 would be back in the back. So let's see what each one says. Choice A says I need to add up all the boys plus my total 100. Well, would it make sense to add Caden, Ethan, Rory, and your total together? No, we never add our total with the parts, because if we made a strip diagram, my 100 would be on top, correct? Because that's how many they want to do. And I would split this up into 4 sections. We have Caden that's 27, Ethan that's 31, and Rory that's 17, and I don't know this missing amount. So if I look at my strip diagram, I know when we would make one like this in class, my kids would always tell me, well, Miss Seitz, you've got to add up these parts and then subtract it from the total. Well, let's see if that one's a choice. Well, let's look at B. We know A's wrong. B says add up the boys and divide by 3. Was there any clue word up there that told us we were going to divide? No. We saw combine, but that was about it. How about C? C says 100 minus 27 plus 31 plus 17. When they put these little parentheses here, they're telling you to do that part first. So they're saying to add up the boys and then subtract it from 100. Well, that's kind of what I was thinking here with the strip diagram. We add up the boys because there are parts, and we subtract it from the 100 to get the other part. So this one may be correct. D says add up all the boys and multiply by 3. Well, there were no clue words up here that told me I was going to multiply, so I don't think that one's right. So my answer would be C. So sometimes when you have these equations with the letter for an unknown amount, maybe try making a strip diagram, because once I did that, that kind of helped me seeing that, oh, my hundreds on top and then I have my parts underneath. I need to add and then subtract to get my other part. And let me see if there is one more. I can't remember. Nope, that was the last one. So we're going to practice these today, and then we'll also practice them Friday. So remember, it just takes a little time to get used to them, but remember the biggest trick that we learned today. If you have a total, your total is always by itself on a strip diagram. So if you have your total next to another number, you can get rid of those strip diagrams. Also, usually when you're writing an equation, the total is usually after the equal sign. Now, there are some exceptions, like this problem, where they put the letter there instead of the total, 100. So sometimes there are exceptions, but those are just some general rules that you can go by to kind of help you.